Remember the integral test, which says that if we have the terms of our series comes from a continuous decreasing positive function, then if we know whether or not the improper integral of f of x converges, it'll tell us that the series converges. Or if we know that the improper integral diverges, then it'll imply that the series diverges. We're going to use this if we know that that the terms of our series come from a continuous function, that it's not too hard to find, that it's decreasing and positive. And here's the most important part. We better be able to integrate this function if we want to use the integral test on it. If we have a series that is whose terms satisfy the conditions of the integral test, we can, and we know that our series converges, we're going to be able to provide bounds on how close a partial sum is to the sum of the series. Okay, so we know that if we have that a series converges, that the limit of the sequence of partial sums is equal to the sum of the series. So we know that the limit as n goes to infinity of the sequence of partial sums is how we define what we mean by the sum of the series. So that means that if we look at a partial sum with a large value of n, with a large enough value of n, it should mean that our partial sum's value is close to the to this limit, to the sum of the series. But the question is, how close? All right, so one way we can approach this is to say, okay, well, what does this sum look like? So if we have the sum from k equals 0 to infinity of fk, we can write this, we can break this up into a finite sum, the sum Sn. So this is going to be the sum of the first of the terms from 0 to n, plus the sum of a tail, so starting at n plus 1 and heading off to infinity. Okay. So this second term is sometimes called the remainder. And you can see that if we have, if we take our sum of the series and we subtract our partial sum, our nth partial sum, we're left with Rn, the sum of the series, where we start at n plus 1. Okay, so it's the sum of all the terms with indices greater than mn. Okay, so the idea is we want to be able to put a bound on how big this term is, how big this sum is. So for example, if we want our answer to be within 1/100th of the exact answer, this answer, we want to know how big do I need to make n to make sure that my remainder term is less than 1/100th. Does that make sense?